Hello there. Today I'm going to do a really quick video, give you a little bit of a demonstration and some explanation on a topic that has been coming up quite often recently for me around performance optimization of ThingWorx applications. What's quite interesting is I've been doing some playing around with this internally and looking at the performance impacts, and today I discover very interesting and perfectly timed article released by Mike Jesperson of the Enterprise Deployment Center here that's called Persistent versus Logged Properties. The purpose of this document in this blog post is to talk about different conditions, use cases of different configurations or aspects of properties. Properties are sitting on a thing, an entity in ThingWorx, and they're going to have different behaviors as far as where we're updating them, whether it be in memory, whether it be in a table for a persisted property for reboot, or whether it be logged to something like a value stream that's going to have time series entries in it, um, or to the table. So if we have a look, it's quite a short blog post, but actually when we come in to find the document here, it is actually quite a comprehensive document, which I would recommend that everyone read. Essentially, it's just taking back these concepts of persistent properties, logged properties, both persistent and logged and in memory only. And these are essentially three configurations or four configurations possible in ThingWorx. And basically what Mike is addressing here is some of the different ways of you can think about the uses of these properties here, when they should be used, when they shouldn't be used, how they can be used together, and some of the overall application and infrastructure architectural constraints that you're going to have between the different choices of these. Now, one thing I will say is that I've seen a lot lately is people might tend to think of these types of configurations as just a checkbox to check when you're setting up ThingWorx and creating your thing model. But you do have to be quite purposeful about your design considerations and thinking about what these values are going to be used for, how often they're going to be updated, if they even need to be persisted, should they be persisted, how and when they should be persisted. So this is really the type of thing that this document gets into. One of the important things here that I'm going to note is that a persisted property goes into the model database using an update. And so this is just a point in time last value that has been received. So for each new value that comes in, if we have a property that's persisted, it's going to be updated, even if the value is actually the same. So if it was 12 before and it's 12 now, the time now is different from the last time it was set to be 12. So it's still going to be updated in the database. And this is going to incur higher overhead in the database operations because there's a couple of database operations that are happening here, as is explained here. There's a new row being added, and the old one is being marked for as a ghost row in SQL Server, a dead tuple in Postgres, and the database activities are going to have to go back and check that out. So in Postgres, you can see this in the properties VTQ table to see how many dead tuples you have in the properties VTQ table to give you an idea of how quickly that's changing on how often these properties are being updated. But the point is there's going to be extra overhead for your database to be adding and doing the maintenance on these old ghost rows. So this is a really good example here, just using an example to say what happens if I have 1,000 connected machines, one update times 60 minutes times 24 hours times 1,000 assets. This is obviously very small amount of property updates, so we might not be thinking of updating a particular property in the database as that impactful, but as you can see here, that this is equating still to almost 1.5 million updates to the table in a day. Obviously that's spread out through the day, but the point here is to say we still are updating the table 1.5 million times, and this is still database resources that we're going to have allocated, have to have available, and be provisioned. And what we often see is that these types of unnecessary and extremely frequent updates can actually be taken away from database operations or other smooth flowing execution of the ThingWorx platform while it's handling these. So this is actually what I'm going to show you today. So I'm not really going to go into the rest of this. It is a very interesting article, but that's really the one thing I want to show you today with this demo is what can it mean when I say a persisted property here, like one insert or one update here. What is that? Sorry, this one. One update. What does that one update to the table equate to if I have some of that on my thing model? So let's have a look. Got to go back a couple screens here. I have some gateway things that are set up in ThingWorx here, and specifically I have a couple of simulators here that are running. So we'd have to do some math here. Basically, they're sending messages every 350 milliseconds, and each of them contain 50 sensors with sensor values, and so that's a pretty good clip. It's not we're not talking about 10,000 writes per second or anything like that. But I did want to create something that was significant. So let's go have a look at what this communication looks like. So just to be clear here, this is going to be a JSON payload coming from each of these gateways. It's going to be opened up inside. We're going to take apart all of those messages, and we're going to bind them to their sensors. So we are talking about 400 odd sensors here, with an update frequency of 750 milliseconds. So looking at how ThingWorx is performing here, we can see the messages coming here in the WebSocket execution processor. Everything is flowing smoothly through the system. I have done a few tweaks to make sure that the systems can both handle the load coming in from those simulators. It's actually possible they're being throttled by IoT Hub because I'm using a really small IoT Hub. In any case, we're going to come down here. We're going to have a little bit of a look here at some of these other things. Specifically, this is a section here on persisted property queue rate. These metrics, you might be thinking these are pretty awesome metrics, and you'd be right. They're coming from the metrics endpoint in ThingWorx. So I mean, I can find these if I wanted to, just by having a look at my ThingWorx server over here. Oops. Once I'm logged in, coming into metrics, and here looking for persisted property persistence. Persisted. All right, we're going to do this a little differently. Let's come back over here. I can never remember what this is called. Let's just have a look at what it's called. Persistent property processing, total writes queued. So let's go and look for this particular metric over in our metrics endpoint here. Okay, there we go. So this is telling us how many properties we have. This is a counter, so we have to look at the counter over a particular time period. Prometheus and Grafana are doing that for us. If you need to do this, if you want to have a look at this on your ThingWorx platform, you can just use this endpoint and take a minute or a 5-minute interval, do a refresh, do a subtraction of the two, and you'll come up with something along the lines of how many persisted property updates did you have for a minute. So we've pretty much got nothing, and let's go and change that. So I'm going to come in here. As I mentioned, I have those the telemetry being processed off of these gateways. This is set up in a thing shape over here, and this thing shape, you can see a couple things I'm going to point out while we're looking at this. there are four persisted properties on here. So because of the fact we got a lot of data coming in here quite quickly, and this thing shape is being inherited by all of these different entities. As I mentioned, there's 16 gateways, but there's more than 400 sensors. So any change that I make on the thing shape, it's obviously fast to evolve, but it's also fast to make some kind of quick mistakes. So this is what I'm going to do here is I'm going to make a mistake and kind of go along with thinking that I would like to know what the last value of the timestamp was last time this particular sensor, all sensors, got any readings. So I'm just going to go ahead and say make this persisted, save it, and this is going to trickle down to all of the entities. Okay, so it took a little while there to queue that up and get that change actually made, but it did look like it was made when I was editing it the last time. Edit. Yeah, okay. So there it is showing as it took. Yeah, okay, there it is. So it took a little bit of time, I guess, probably to get all the entities restarted. But now that that's taken, essentially any time that this timestamp is going to be updated on the model. Previously, that was running just in memory. This was the in-memory option. It is being updated, so we had the last timestamp of the sensor values. And let's come and have a look at what this looks like in ThingWorx here. Okay, so kind of starting from the top, everything still looks fine. Data coming in, data being processed. Um, it is a fair amount of data, so the event processing queue is quite busy. I've got it set to core pool of 250 threads. You can see 172 of them are active. Trying to make all this happen is going quite smoothly. The no queuing that's happening until we get down to here. So the persisted property queue rate, you can see that it took a little while for it to get started. We have kind of peaked out here at this top end total rights queued, which is going to be related to the speed at which these are coming in. When we look in the middle here, we see that actually we are starting to queue. So we have 20 processing threads that are allocated for handling these persisted properties, but the queue size is building up. It's not very big, it's only 10. But some of those entries are being queued, and meaning they're not able to be executed right away. So we do have a pattern here that's matching on the execution rate of these persisted properties compared to the submission rate, which is pretty much what we would want to see here, meaning that we're executing similarly to how we're getting them coming in. Got a fair amount of stuff kind of happening here, so the good thing is the queue isn't really building, it's actually decreasing. So this is good, but this also means that if I did add any more in here, then this would quickly be backed up, and there's all these persisted property updates that I'm trying to execute around 1500 per second would essentially start to cause other database issues. So speaking of database, let's just come over and have a look at the database to see how it's doing. And yeah, so we're going to have a look at the times here for a second. Okay, so 2042. Okay, so that was before. We don't actually have a whole lot of database activity. I'm looking at the wrong thing. So we do have an increase of 15 and a half versus, yeah, 0. So we do have about 15% of our DB is being used for, maybe we can have a look at over here. This is essentially this peak, we got it up to 100 here. That's why we're not seeing it on the other graph, is because I've got max shown as opposed to average, where you can see that's a little bit lower. But I got a significantly sized database here. This is obviously not anything kind of production scale database, but what I wanted to show you was that just by clicking that one property, kind of that small oops, I forgot that, or oops, I didn't think about the fact that I shouldn't be updating that property value every time that value is coming in from the field or from a remote device. Well, the situation is, I've got about 20% of my database that's being consumed, and I'll, have tens of millions of updates to that table if that was the normal operation for my system. So yeah, and see here it's actually going higher. It's going higher, but because I believe ThingWorx is probably trying to get caught up. Let's go see how it's holding up. Yeah, so it's flattened out. The queue is coming down, so it is managing to do this. You see it's doing some batching here. This is the yellow line. So it's doing some batching across particular entities because the threads, the entities that it's updating are distributed across these 20 threads. And so some of the calls are being batched to try and make this as efficient as possible. But basically the short answer is I shouldn't be doing what I'm doing. And just be very careful of this type of configuration because it's pretty easy to check these boxes in ThingWorx Composer and kind of forget about or not think about the fact that this is going to have significant downstream performance issues when you do try to roll these types of things out into production. And something along these lines, although it might seem a little bit strange and potentially unrelated, it can cause instability in the platform as well as causing other issues to present themselves. Like if you're trying to do another query, here we're using a lot of database resources. We could be tying up database resources and connections, so you might not. You might be having to wait for those to become available. I have done some pre-tuning on my system so that this ran smoothly, but the default configuration of ThingWorx would not have gone as smoothly as this did. All right, hope you enjoyed that and have a great day.